Hey guys, it's Will from Tested.
And Norm from Tested.
Norm, you have what looks like a whole bunch of little tiny boards.
It's very
spread out in
scary.
front of you. This is all new for you. I mean, maybe not all new.
But this is people may have heard about this.
Yeah, these are all microcontrollers. They're mostly Arduino microcontrollers. I've been learning about those for the last 4 or 5 months now.
It's a very hot buzzword.
It is a thing that is popular. I've had curiosity about it for a long time. I was scared of the programming because you have to be able to do a little bit of C programming in order to use this stuff. And we had bought a board 2 years ago, probably at Maker Faire, and it literally sat in the office and just was kind of aging quietly to itself. And finally, I was like, "Look, I'm gonna do this. It can't be that hard."
Electronics.
Yeah, I took C in college. You know, it's not a super scary thing.
Objects, loops.
You have
There
all
you
the
go.
pointers.
There
You don't even need to use pointers.
They're like mailboxes.
Pretty much, yeah. So since then I've gotten kind of crazy and I bought a bunch of Arduino stuff.
So let's go over what you've bought, what Arduino is,
So let's talk about what it is.
and what you can do with it.
And what our goal here with this video is, because a lot of people have questions about this stuff. It's a little bit confusing. It's pretty well documented once you kind of get the basic lingo, but if you don't have the basic lingo, it can be a little bit scary. So what Arduino is a open source hardware and software. There's software as well. That is a microcontroller.
It's a family of microcontrollers.
A family of microcontrollers. And what microcontrollers are basically are small embedded processors, ARM processors typically, that you can use to write software that interacts with the real world. So a microcontroller, that one that you're holding in your hand, is an Arduino Mega. It's the big one right now.
So this whole thing is an example. It says Mega right there. It's
Exactly.
Arduino Mega. And the processor.
That's the processor.
Very essential
It's a
component.
32-bit low-speed ARM processor. I think it was like the 32 megahertz or something.
All right.
But what you use it for is if you want to take input from the real world and use that in a computer program, or output data from a computer program into the real world. So, for example, the simplest explanation I can give is if you want to turn on or off a light switch. If you want to turn on or off a lamp over the internet, you can do that using an Arduino. You would write a simple program, build a circuit that can switch 120 volt AC from the wall, and interject that between your wall switch and your wall socket and the lamp.
And there are many other different microcontroller platforms that all have processors, inputs, outputs, and different features.
Some are more capable, some are faster, some are x86 based instead of ARM based.
Arduino is just very popular because they've been doing it for a long time.
They're 5 years in
open
at this
source.
point.
There's a lot of code, and so it's easy because there's a lot of code. Very easy for people to get in.
Well, and the nice thing about Arduino is because it is open source and it's designed for prototyping. So our friend Jeremy Williams has built a couple of Arduino-based projects, and what he's done is used the basic Arduino boards you can buy in the store to do the prototyping, and then he's gone out and had custom boards made with the same CPUs that run the same software that have exactly the inputs and outputs he needs. And if you're going to do a larger quantity of this than just building a handful, it's much more cost effective.
So while you can buy a board, an Arduino board, whether it's this Uno or the Mega, with a processor, inputs and outputs,
that's $25 or $30.
Right. You can also buy just the processor to meet your needs.
Have somebody in China assemble the processor and the board that's exactly what you need for $5 or $10 per board.
Right.
Depending on quantity and scale and all that.
And it'll still run that same code.
Exactly the same code. So you use this as a way to design and do the kind of grunt work, and then when you want to make something a little more polished, you can. There's a wide variety of Arduino boards out. We're not going to get into the real nitty-gritty specifics between the different ones, because quite frankly, if you're just starting out, then there's a handful of boards that you can start with that are going to be totally sufficient for whatever you want to start with. And then if you want to go deeper later on, the difference between a cheap Arduino board and an expensive Arduino board is the difference between $15 or $20 and $50.
So what are the attributes of a board that you might want to look at?
The things that matter are, on a high level, the number of inputs and outputs. Okay. So there's two types of inputs and two types of, there's two types of inputs and outputs. There's analog and digital inputs and outputs. On most boards, at least the ones that I've used, you can usually configure each analog pin and each digital pin as either an input or output as you wish.
What's the difference between an analog and digital?
So an analog pin will read a sensor that provides a much wider variety of signals. A digital one is either on or it's off. Now, to complicate matters further, when you're doing digital output, you can do this thing called PWM, which stands for pulse width modulation. You use that for digital signals like LEDs. If you want to turn an LED on or off, typically it's either full blast, whatever voltage you're piping through the system,
but
or completely off.
But if you turn it on and off at a very high frequency,
exactly,
then you can simulate granular levels of output.
You can make it essentially indistinguishable from an analog controlled dimmer switch to the human eye.
And so if you go shop for an Arduino board, they will say, X number of inputs, X number of outputs, and in parentheses, how many subset of those are PWM.
Exactly. The other things that matter, and this is stuff that matters more as you get further in and kind of do more advanced projects, but the type of CPU that's on the boards makes a difference. For example, on that Uno board that you're holding in your hand, there's no native USB capabilities. So in order to program the board, you basically install a driver that fakes a serial port on your computer, whether it's a Mac or a PC, and then it pipes that across like it's a 1990s era modem. On the newer boards, I remember they may not even be newer boards. It's really unclear to me what the timeline on some of this stuff is. But like the Leonardo, which is over here where you can't really see, we'll scooch it over in a minute, or that Mini, the one on the far left, they have native USB support. So not only can you program that device without really using a driver, it'll also mimic a USB keyboard or mouse if you want. So you can connect, for example, if you want to make an arcade stick of your own, custom arcade stick, you could totally do that by using a Arduino that has native USB support and piping it through to setting up so that it uses the MAME default hotkeys for up, down, left, right, buttons 1 through 4, buttons 5 through 8.
Let's give people an example of what you can do with...
Hold on, a couple of other small things. Different controllers have different clocks. Have different oscillators. Some of them use crystal oscillators. Some of them use something like a resonator that seems to be much less accurate from my admittedly neophyte stumblings with the boards. I found that the Leonardo and the Micro have much better, much more clock accurate when you're dealing with stuff that's in the microseconds and faster.
And there's also different firmware that goes for all these boards.
No, so the firmware
all the same.
So the way the firmware works is I guess there's a stock like bootloader or something on it. I don't actually know how this works. You don't have to know how this works, which is the nice thing. When you write a program for it, though, you upload it to the board, and I mean we can switch over to the computer. I can show you what the IDE looks like. I have a couple of sample programs open.
Okay.
So this is the Arduino IDE on the left side of the screen. It is just a big ass text editor, and it's context aware like a modern text editor. So it color codes the syntax stuff so you don't have to know that. Stuff that's light gray are comments or notes. Stuff that's yellow are, I guess, declarations, or orange are declarations, and blue are variables.
And you're not required to write all this code by
So
hand.
I wrote all this code by hand, actually.
So, okay.
We can talk about that in a little bit. It looks kind of daunting now. I started with a moderately complex program, I guess, here. But the nice thing is there's a ton, because Arduino's been around for a long time, there are literally thousands and thousands of programs out there that people have written, posted to the internet. So you can go through and not only crib from their programs if you need to, but you can also look at how they wrote their programs and see how they made their project work, which then helps you figure out how to make your project work.
And if they share their code, you can just copy the code, and if it's well annotated, you'll know what the variables change.
Even if it's not, and you're reasonably competent at C, right, then you can usually figure it out. And just to be clear, reasonably competent in my terms means I think 1 semester of CS 100. So in 1993, so a long time ago in a galaxy far, far away. To program the board, I'm plugging this in over here. This is an Uno with a shield. So the other thing that we should talk about is there are these things called shields. That's what this guy right here is. Yeah, and there's a bunch of different ones. There's ones that let you connect to Ethernet and Wi-Fi and Bluetooth and Zigbee, which is like a mesh networking
We say
standard.
shield, it's just another flat piece of circuit board that goes on top.
Exactly.
And it's in this, if you notice, between like these two Arduino boards
and the Uno as well.
And the Uno one, it's the same size, so a shield that's compatible with Arduino will be...
Mega is a little bit different because they're typically bigger, but the Arduino, the the original Arduino boards all use similar size shields. Mm-hmm. You have to be careful, but usually when you buy the shield, it says, hey, this is compatible with these 6 Arduino microcontrollers. And this is another way that lets you prototype. So if you were making this product for mass consumption, you would go to China and you would say, hey, I want to have an Ethernet, I want to have this Ethernet controller and this and this and this, and that's how you would do it. Since we're not doing that here, I'm just doing one-off projects than the one-off shields. This is just a blank shield that you can use to solder up the circuits that you want. So to program it, you could drag it over, Norm. It's relatively sturdy. It's soldered on relatively shoddily.
All right, so
it's
plug it
embarrassing
over
to show
USB.
this in public because I did a really shit job of the soldering. Plug it into USB. You can't see it now. There may be a LED on the top shield as well. I can't remember. But there's an LED on. It's powered. The program's running right now. I'm going to hit upload, and what that's going to do is upload the new version of the software. Unfortunately, I took off the Hall sensor, and I haven't put it back on yet, which is what makes the switch turn on and off. So it's not going to probably turn on. But once you upload the program, it stays, even if the power is off. And you don't have to maintain the USB connection to keep the power running. You can plug in a 9-volt battery adapter into the power plug on the side of the board. You can plug in USB power. You can plug into a standard kind of issue wall wart that has a 9-volt half amp output. And that stuff just works. There's nothing to it. You really, like, it's very straightforward, and once you write the program and upload it, it's self-contained and it runs on its own as long as you give it power, which is pretty cool. That means you can do things like install this someplace that you may not necessarily have access to electricity and just use a 9-volt battery or a lantern battery or something like that if you want it to run for a long time. I'm trying to think what else we should talk about. The software is important. There's a couple of different options for this. If you don't know anything about programming, there's a great book that Make Media publishes called Getting Started with Arduino by Massimo. I'm forgetting to spell his last name. It's in the box over here. Anyway, just Google Getting Started with Arduino. You can get it on your Kindle. You can buy a paper version if you want. A lot of kits come with it. It explains very core programming concepts from a very low level. So if you have any kind of programming experience at all, it's probably going to be too simple for you.
And also, you mentioned a kit, and so you can buy something just one board.
You can buy a bare board for $30.
You can also get a kit, which will have a lot of the sensors and a lot of the breadboard stuff that you might need.
Yeah, so we can show that too.
Yeah.
So this guy over here is a Leonardo with another project that I'm working on right now, and you can, if you want to plug in power, I can show you what it does. I've lost my power cord here.
I have USB in here.
Okay, yeah, you can plug the USB in. That'll do it. So when you plug the USB in, it'll take a minute to power up. This is a countdown timer. Don't lift that. Yeah, be careful of it's just resting in a breadboard. Let's talk about what this is before we tell everybody
Let's talk
what it
about
does.
all the components of what's going on here.
Okay, so this looks like a horrible snarl. I'm sure that people who are good at this are going to do a much better job than I would, but you can post your criticism in the comments.
So you have your Leonardo here.
That's for all intents and purposes, a normal Arduino board.
Right,
yeah.
there's the processor, and then you have plugged in.
So in those headers on the side, I have jumper wires, and this is one of the things that you get when you buy a kit. You can also buy just a bundle of like 200 jumper wires. They'll be in a variety of colors and lengths, but basically what they are is, and you can pull one of them out if you want. It won't hurt anything. Just remember which one you plugged it into. So it's a little metal pin with a wire attached. And it lets you connect into those headers, those big things on the side of the board, without any kind of, very easily and very quickly. The other end of this goes into a breadboard. I'm going to show that on this side because the breadboard's kind of messy. So that's just a blank breadboard, and you use that to generate circuits. So the way these work is, the ones down the side, the vertical rows on either side are power and ground. So the hot wire and the ground wire.
So that's why you see the plus and minus.
Right, and those are connected vertically. The ones on the inside portions are connected horizontally, and they aren't connected across this middle channel. So you can do things like connect 3 wires here that'll all be run in a circuit without having to actually solder 3 wires to each other. Mm-hmm. It's a shortcut. If you took electronics in high school, you know how to do this stuff. Once you understand the core concept, it makes tons of sense and is very quick. It's much faster than even alligator clipping wires to each other to do the kind of stuff you need to do. And yeah, that's what I was going to say. Is with the smaller boards, like the Micro, and I think the Nano as well, they'll bridge that center channel so you can really, really easily prototype some basic circuits. And you just jam it down in the holes, and it gives you connection. It gives you connections to all of the pins on the board. I didn't know that those micros existed when I started, and if you want to learn with a basic processor, it's a pretty awesome way to start.
This comes in a kit.
Most kits come with a couple of different breadboards. Some will come with a prototyping shield, which is a Arduino shield that you basically snap a breadboard in, and it gives you a place to have all the prototyping stuff. just on one container.
All right, so back to this project.
So what I've done there is I have 3 or 4 elements. The big screen, which is upside down on the video, but that's fine. You can rotate the whole thing around if you want. Is what's called a matrix display. So this is made by Adafruit, which is one of the companies that makes stuff that contributes to Arduino and Raspberry Pi and BeagleBone and all that stuff. Each of the lights on this kind of LCD display is individually addressable. So in order to make things like numbers or letters pop up on it, you have to have a library and some code. The good news is the Adafruit folks have already written the code. All you need to connect to this, exactly. You download the library, integrate it, list it, declare it at the start of your program, of your sketch, which is what Arduino calls programs. And then you can just use a series of simple C commands to write text out to that display, or numbers in this case. So what this is the podcast countdown timer. We've been doing podcasts with your Canon 6D, which has a 30-second timer. Now the program's still buggy. I've completely rewritten it, and I have the old version here, so it's not particularly awesome right now. The 3 elements to this are the screen, the switch, and I think there's a speaker too.
Yep,
so
right
the little piezo. It's not particularly loud. I need to get a better speaker for this. The piezo was not the right answer. But what happens is when you press the button, it switches modes. So I'm just switching. When I press the button, I move from one loop to another loop. You press the button again, it'll go to another loop. And so what it does is it gives me a 5-second countdown so that I can sync up the video and the audio. And then it goes to a 30-minute countdown, which is coincidentally the time limit of recording on your camera, so that we don't actually run out of time at the end of the podcast like we have in the past.
Very good.
So the next step for this is to solder it all into a shield. Maybe put in a clapper or something dumb. Maybe just build a box for it.
Design a box for it. 3D print a box for it.
And I think that LED lights up. I haven't built a circuit. I need to build a circuit that brightens the button. The button has an LED inside that lights up when it gets to the 5-second countdown. I need to step up the voltage so it'll be a lot brighter because it's not bright enough for what I want. But that was the result of like a good afternoon, maybe 2 afternoons.
And completely programmable.
And it's completely programmable. Like if I wanted that to be a count up clock, whatever, you can do whatever you want. If you want to make an alarm clock,
it can be all those things.
Yeah, you can do literally once you learn the core pieces. And the nice thing about it is like programming, you learn how to do one thing, and then that's in your wheelhouse forever.
Yes.
Then you add things and add things and add things, and pretty soon you have a pretty good skill set and a much better understanding of how all of this stuff works.
Now, what if you found a lower cost alternative and you didn't want to buy something that was Arduino branded?
So that's the other thing. In the last couple of years, tons and tons of different vendors have both made Arduino clones, which is totally cool, open source hardware, added their own IDEs to it, maybe changed the way the hardware works, tweaked the number of inputs and stuff to be more specific to robotics or drones or something like that.
And because Arduino is open source, these things can be compatible with Arduino shields and other...
Exactly, yeah. So you can use an Ethernet shield that's an Arduino Ethernet shield in some cases, not in all, but with one of the clone projects. For example, the turret that's over there on your left uses stuff from, I think, Arduino, which is a kind of custom... They're one of the places that make, I believe, custom Arduino based boards. And that's a control board, and then there's a motor shield on top of it that provides a ton of little 4- and 3-pin Molex connectors to control many more motors than are being used on that particular turret robot. The other thing, the little guy you had, is something we found at Maker Faire. A reader of the site who happens to work on this stuff came up to us and said, "Hey, I have something you should check out." I actually plugged it in earlier this week. It's a Galago, I believe. Is that right?
Galago is the name?
Galago microcontroller, and they use a web-based IDE. So you basically install a downloadable TSR. I think it's Mac only for now. There's a CLI version for Windows, but that's coming soon. And it's brand new. You do all the work inside your browser. So it will connect to multiple devices at once. So if you have 4 or 5 different microcontrollers in your project, like you're building a robot or a drone or something like that, you can actually address all of them and write the code to them all at once. Whereas with the Arduino, Arduino Ide, it's a little bit of a hassle.
Yeah, and then there's stuff like the Arduino robot, and then even
so let's start with this Splora, because I think it's the little more basic version of this. But the typical Arduino boards, the only kind of inputs and outputs they have is generally there's like an LED that flashes that you can flash to make sure that things are working. Yeah, and then you add your own stuff.
Right.
The Explorer was the first departure from that. It includes a ton of inputs and outputs. It looks kind of like a gamepad.
Yeah.
It looks like a naked gamepad, I guess. On the left, you have a joystick. There's a linear potentiometer on the bottom. There's speakers, light sensors, microphones. I think there's a gyroscope, accelerometer, a couple of digital buttons. There's a bunch of these things on the top edge called Tinkercad connectors. I'll show you. That's what these guys are. I think the orange ones are inputs and the white ones are outputs, or maybe it's the other way around. But you can use them to expand in a solder-free way. So I think this is designed kind of for educational markets where they may not want kids using, super hot soldering irons, or that may not be a good thing to start with. There's a couple other things you can do with it. There's a header that works with a couple of different small LCD displays. The one on the top of the robot is actually compatible with this. So that is a Computron, I think, 1.7-inch TFT LCD. And it just has two headers that plug in, and if you have the right libraries, you can use that with the Explorer programs.
So plug this in.
It's really cool. And if you want to plug that in, I have Pong loaded on that. It's kind of a crappy version of Pong, but it's the demo code. And you can just unplug and replug this stuff. It's relatively sturdy. Some of the early Arduino boards, like the Du Milana Ve, if you listen to the podcast, you know I killed a MacBook using that. But for the most part, it's the newer boards. It's really hard for you to pump enough voltage back to the USB port that you actually kill something. So I loaded Pong, which uses the LCD screen. It's just one of the demo programs, and this is one of the nice things about Arduino is that in addition to the wide community and dozens and thousands of programs that are out there, there's also pretty good example programs with most of the projects. And you can use Pong with the joystick. It's not a particularly good version of Pong, but it kind of highlights a lot of stuff about Arduino that's worth talking about. This isn't something you're going to play games on. Like if you want to play emulated arcade games, bust out a Raspberry Pi or something like that. This is really very specifically for control and input and output. We saw a guy at the Stanford Robotics Fair who used an Arduino as a signal processor, which is crazy. I mean, he basically emulated a really expensive piece of hardware with a $25 board to do IR signal analysis. The other thing that they just rolled out at Maker Faire, it's brand new, is the robot.
Arduino robot.
Yeah, the robot is actually, there's two boards. The bottom board is the motor board. The top board is the control board. They both use Leonardo processors, so they have native USB. You're not probably going to use that with this, but I think it's just what they are using these days. There's a bunch of those Tinkercad connectors around the outside edges of the device. I think that's the right way, I think, yeah. Yeah, that's good. It's got two motors, drives with kind of skid steer tank style controls, so you can go left and right. But it's an autonomous robot. It actually comes with enough default sensors. I think there's a compass, some infrared sensors. I want to say an accelerometer and gyroscope, but I could be wrong on that. A potentiometer, a D-pad, and then a speaker, and the LCD screen comes with it as well. That you can actually get started programming robots
without buying any extra sensors.
Yeah, it's kind of expensive. It's like $260. But if you compare it to other comparable kits, it's a very, very good deal, especially for what you get. Like the kits in that price range are typically much less impressive than this. It comes with batteries. It's 4 nickel metal hydride rechargeables. You charge them by plugging in the robot. You don't have to take the batteries out or anything. And it includes the kind of stuff that you need to get feedback that I have found I haven't had that much time with it yet because we've been really busy since Maker Faire. But you can kind of, it's going to drive, it's going to go south or maybe north. So you can write programs that use the sensors. You might want to just turn it off. You can write programs that use the sensors and learn about, and like the Explorer and the other devices and the Adafruit screen, it has built-in libraries that give you a series of relatively simple commands to control the robot.
Very cool.
It is much more complex than the other stuff. It is not a good place to start with Arduino.
No.
Start with the micro.
This is to get into robotics.
That's if you want to get into robotics. I guess the next thing to do is talk about like where you want to go if you want to start. If you want to get started. The thing I would recommend is finding a kit. Make sells them, Adafruit sells them, SparkFun sells them.
When you say kit, you don't mean like a specific make one thing with Arduino.
I mean, that's a fine way to get started. Like if you want to learn how to make a clock, then you can do that and it will help you get started. But you probably won't do as much programming, which is where the real learning comes.
So you want to open-ended, here's a bunch of stuff kit.
Figure out a project you want. The first thing I did was this Leonardo kit, which unfortunately I've broken before I brought here, but it's to put lighting in my pantry. This is the dumbest thing ever. I could put some sticky under shelf lights that probably do just as good a job. But this is going to be cool. It's fun, and I've learned a lot, which was really the goal more than anything.
And how much are these kits typically?
So the starter kits include usually a couple of breadboards, a shield that will maybe help you prototype faster, stuff like that. And then a whole bunch of the jumper wires. You'll need resistors to get started. You'll need some LEDs to get started. You'll need some like push button digital buttons. And typically those range from anywhere from like $75 to $200, depending on what comes in them. My advice is to get the most general, like go cheap on this. Get a kit that has an Uno board. Don't spend a ton of money on it, because what's going to happen is you're going to get going. As you start messing with this, you're going to come up with the perfect project, and then
you're going to buy the things you need for that.
You'll buy the stuff one thing at a time.
Right.
Although it is nice to have a variety of sensors to kind of noodle around with. Like having a sound sensor, having a light sensor, having that kind of stuff is handy. And that's another place that the Tinkercad stuff can be pretty useful. Or Tinkerkit, rather, sorry. To learn the programming side, if you have any kind of programming knowledge at all, if you know how to do any kind of...
taken one semester of college level programming?
I would say anything that's not like HTML, anything that's not like a markup language, whether it's Python or COBOL or C or Fortran or any of the stuff that they teach in college or community college, or you know how to write JavaScript even probably. If you know how to make loops, if you understand enough about syntax in one language to pick up the syntax in another language, just go straight to arduino.cc, look at the reference section, and they literally have sample code to get started, and then pages and pages and pages of all the available functions that you can use depending on which libraries you initialize. Each of the boards, the Arduino Uno, the Leonardo, the Mega, all have getting started pages. They're less important for the kind of basic boards than they are for the Robot and the Splora, which have some specialized hardware on that you need to kind of learn how to use. And then look at places like Makershed, SparkFun, Adafruit. They have all sorts of kits that will kind of give you ideas, maybe start you in one particular direction. You can buy things like this. This is, I should have opened it beforehand, but this is just a laser cut box for an Arduino Uno.
It's a housing.
It's a housing. So if you have a project that you've built and you want to put it in here, you screw the board onto a piece of acrylic on the bottom, set it in here, and it's protected from elements or whatever, and has ports on the side. So that kind of stuff is all readily available. It's not particularly expensive. If you have access to a 3D printer or a laser cutter, you can make that stuff very easily yourself.
And you can also buy this stuff in physical stores, P&M stores.
Yeah, so Radio Shack has, well, not all Radio Shacks, many Radio Shacks sell Arduino stuff. They're typically a little bit more expensive than, say, the Amazon, Adafruit, or SparkFun prices, but the
convenience of wanting to do something and needing a button.
Radio Shack's a mile from my house. Yeah. Amazon also stocks a lot of this. I tend to like to support the small guys on these projects just because they're actually doing the legwork. If you look at the different boards, like the Micro was designed with Adafruit. The Robot was designed with CompuBot, I think. I can't remember the name.
Spanish company.
Yeah, they make robots. Yep. So yeah, it's a really cool thing. When you combine that with things like these guys, which are just LED strip lights, you can do all sorts of really amazing stuff. The LED strip lights are incredibly cheap if you get single color lights. They're $15 for 5 meters.
And it's just, these go into...
there's these, they have connectors. So you can cut them on the lines, which are every 2, 3, 4 lights depending on the strip, and show them that. And then you can either solder directly to those pads, or you can do the connectors, which are much easier and faster. So that's kind of, do you have any questions? Yeah, do you have...
you can go online and go to a store and buy a book.
Exactly, or just look at the reference stuff online if you have any kind of programming background. It's really fun.
And it's, having the programming background probably is the biggest hurdle.
It helped.
And if you don't have any programming background, reading a book will get you to where you need to get started.
The good news is if you don't have a programming background, don't let it scare you off. Because the type of programming that you need to do is not at least to get started, isn't super complex. It's not. You don't even have to understand pointers really. You need to understand while loops, for loops, if loops, and if you can do that stuff, you can kind of do something that's kind of neat. It was much more satisfying, at least for me, to learn programming stuff using things that give me physical feedback than it was to write some dopey command line program when I was in college. So, if you tried programming in school or whatever and didn't get into it, maybe give it another shot. This is a good way to do it, and for $100, you can have a lot of fun.
Lights are fun and exciting.
Yeah, lights, buzzers, beeps. You can make something that'll torment the dog, if nothing else.
There you go.
So that's introduction to Arduino. If you have questions, post them in the comments. We'll be watching, and I'll try to answer what I can.
Share your projects.
Yeah, we'd love to see what you guys are doing. If you have good projects, send them to tips@tested.com, and we'll post the best ones. I guess that's it, Norm.
That's it.
See you guys later.
Bye.